Think about this. Right now, you're surrounded by a hidden force holding your entire world together. From the shoes on your feet to the drywall in your room, and even the smartphone in your hands. Everything relies on a substance we completely take for granted. But here's what nobody tells you. If all the glue on Earth suddenly vanished today, airplanes would literally fall apart midair, skyscrapers would collapse, and global trade would grind to a screeching, chaotic halt. Most people never think about this, but making something stick is one of the most violent, chemically complex, and terrifyingly precise processes in modern manufacturing. Imagine trying to fuse two pieces of solid steel without using heat, welding torches, or bolts, and expecting them to hold under 10 tons of shear pressure. That is exactly what industrial adhesives do every single second of the day. Today, we are taking you past the warning signs, deep behind the security gates of a high-tech chemical fortress, to see how raw, volatile chemicals are transformed into unstoppable sticking power. What happens next surprised even experienced engineers, because a journey from a crude, sticky sludge into a hyper-purified liquid masterpiece is a masterclass in extreme physics. Get ready, because we are about to reveal the explosive secrets of how glue is actually made. Our journey begins thousands of miles away from the store shelves, in the rugged oil fields of Saudi Arabia and the sprawling petrochemical complexes of Texas. Most people think glue is just boiled animal bones, but modern superglues and structural adhesives are actually born from deep underground petroleum reserves. We pull crude oil from the earth, transport it across oceans in massive supertankers, and distill it down until we isolate a highly volatile, clear liquid chemical called cyanoacrylate. This raw monomer is so chemically sensitive that a single drop of stray moisture from the air can cause an entire multi-ton batch to instantly flash freeze into solid plastic. But petroleum is only half the story. To make eco-friendly with glues and packaging adhesives, we rely on vast agricultural supply chains. We travel to the dense cornfield of Iowa and the potato farms of Germany, where millions of tons of crops are harvested to extract pure starch. Inside specialized refining mills, these starches are processed into a hyper-purified powder with an exact purity rating of 99.8%. This powder is packed into enormous 2,000-pound industrial super sacks and shipped thousands of miles across the globe to the blending plants. But as these massive sacks of white powder hover over mixing vats, an invisible, deadly hazard fills the room, and one tiny spark could blow the entire building off the map. The environmental cost of keeping our world stuck together is a massive, high-stakes battleground that engineers fight every single day. Extracting these petroleum bases releases carbon, and the refining process consumes millions of gallons of water per hour, requiring advanced, closed-loop filtration systems to prevent toxic runoff. Factories must capture every single vapor cloud of volatile organic compounds before they escape into the atmosphere, utilizing massive carbon bed scrubbers that cost millions of dollars to maintain. Yet, despite these extreme safety systems and green initiatives, the raw ingredients sitting in these holding tanks are still incredibly unstable. If the internal temperature of the storage silos shifts by even a few single degrees, a catastrophic chemical chain reaction will trigger, and the results are absolutely irreversible. Now, step inside the heart of the compounding room, where the true magic and extreme danger begins. We start by pumping thousands of gallons of our liquid chemical base into a colossal, 3-story tall pressurized reactor vessel made of solid reinforced stainless steel. The air here smells intensely sharp, a mix of biting vinegar and heavy sweet alcohol that forces every human worker to wear full-body hazmat suits and oxygen respirators. The giant internal blades of the mixer begin to spin, rotating at a blistering speed of 1,200 revolutions per minute, churning the liquid into a violent, roaring whirlpool. Suddenly, the automated system injects a specialized acid catalyst, and within a split second, the molecules inside the tank begin to frantically tear each other apart. Watch closely as the computer-guided thermal jackets flood the outer walls of the reactor with superheated steam, driving the internal temperature straight up to exactly 135 degrees Celsius, or 275 degrees Fahrenheit. The pressure inside the vessel spikes violently to a crushing 4.5 bar, which is more than 3 times the pressure inside your car tires. You can hear the metal of the massive tank groaning under the immense strain as a chemical reaction, known as polymerization, hits its peak. Under this extreme heat and crushing force, isolated small molecules are forced to violently chain together into long, tangled molecular ropes. It is these microscopic chemical ropes that give the glue its ultimate strength, allow it to stretch, grip, and never let go. But if we let this reaction run for even 60 seconds too long, the entire batch will instantly lock up into a useless multi-ton block of solid acrylic plastic, ruining $100,000 of material. To prevent this disaster, the automated control system suddenly cuts the steam and instantly floods the reactor jackets with ice-cold glycol, dropping the temperature down to 20 degrees Celsius in less than 2 minutes. The violent roaring slows to a thick, deep hum as the liquid transforms into a crystal-clear, syrupy fluid. The batch is safe, but it is still far too thin to be useful on a construction site or in a factory assembly line. Next, the machine opens a massive bottom valve, discharging the hot, thick syrup into a high-speed secondary blending tank to receive its secret additives. Inside the secondary blender, automated hoppers drop precise amounts of fumed silica and synthetic rubber polymers into the swirling mass to give the glue its body and flexibility. The machine churns this heavy paste under a powerful vacuum of -1 bar, pulling out every single microscopic bubble of trapped air that could weaken the final bond. Workers monitor the heavy machinery through reinforced glass viewing ports, watching the swirling vortex transform from a clear liquid into a smooth, milky white or amber adhesive paste. This intensive mixing phase lasts for exactly 4 hours per batch, running completely nonstop until the texture is flawlessly uniform. But even though the glue is perfectly mixed, it is completely useless without the final, most dangerous ingredient, a secret chemical stabilizer that keeps the glue alive but highly volatile. This crucial stabilizer acts like a chemical muzzle, freezing the molecules in place and preventing them from bonding with each other while inside the bottle. But the moment the stabilized glue leaves the dark tank and encounters even a single molecule of moisture on the surface, the muzzle is stripped away and the glue cures instantly. The finished batch is pumped through heated stainless steel lines at a rapid rate of 50 gallons per minute, moving directly toward the automated packaging zone. Here, thousands of empty plastic bottles are flying down a high-speed conveyor belt at a blistering speed of 12,000 units per hour. But as the filling nozzles descend to inject the liquid, a freak static electricity charge in the air threatens to spark an uncontrollable flash cure that could jam the entire automated assembly line. To survive this high-speed chaos, the factory relies on an elite army of advanced robotic systems and hypersensitive digital scanners. Before a single drop of glue enters a bottle, high-resolution AI vision cameras scan the containers at a rate of 200 frames per second, checking for micro cracks thin as a human hair. If a bottle is warped by even a mere 50 microns, a high-speed pneumatic blast of air instantly shoots it off the line into a recycling bin. This automated quality control system operates with an ultra-strict tolerance level, maintaining an incredibly low defect rejection rate of less than 0.01%. Every single movement is completely automated, running with the fluid, rhythmic precision of a mechanical symphony. Once filled, random samples from every single batch are immediately ripped from the line and sent directly to the high-tech stress testing laboratory. Here, heavy-duty automated hydraulic pull testers clamp two pieces of bonded metal and pull them apart with a terrifying force of up to 3,000 psi. The metal bars groan and bend under the immense strain until, crack, the metal itself tears completely in half, while the glue joint remains perfectly intact. Technicians inspect the fractured samples under high-powered electron microscopes to ensure the product meets strict international quality standards like ISO 9001 and aerospace structural certifications. This relentless testing ensures that when this adhesive is used to bond the panels of a commercial airliner, it will never, ever fail. But even in this world dominated by computer-guided lasers and multi-million-dollar robots, there's one critical moment where human skill completely beats the machine. Every single afternoon, a master chemical blender steps up to the quality testing bench to perform the legendary tack and draw test. Clad in protective gear, they dip a specialized stainless steel spatula into the fresh batch, lifting it up to observe exactly how the adhesive stretches, breaks, and drapes under gravity. No digital sensor or computer algorithm on Earth can replicate the human eye and tactile feel when judging the delicate, artistic balance of adhesive rheology. If the master blender senses even the slightest imperfection in the flow, they can halt the entire multi-ton factory production line with a single press of a button. That human moment happens during the critical line startup and material changeovers. When switching from one type of plastic resin to another, the massive extrusion machines must be manually purged and calibrated by a master technician. A human operator must read the subtle changes in the texture and color of the molten plastic as it emerges from the die, adjusting hidden manual valves by a fraction of a millimeter based entirely on touch and decades of experience. An AI can read data, but it cannot feel the elasticity of a hot polymer bubble or hear the subtle change in a bearing's hum that signals an impending breakdown. Once the human master approves a line, the automated system takes over again, launching a global tidal wave of production. The scale of global plastic bag production is so massive it is almost impossible for the human brain to comprehend. Every single year, factories around the world churn out an astonishing 5 trillion plastic bags. To put that into perspective, that is over 13 billion bags every single day, or an incredible 9 million bags every single minute. If you tied all the plastic bags produced in a single year together end to end, they would wrap around the entire planet Earth more than 100 times. This massive industry drives a global market value exceeding $45 billion annually, making it one of the most lucrative sectors in the entire plastics manufacturing empire. To wrap your head around just how wild this technology is, here are 3 shocking facts most people have never heard. Did you know that the structural adhesive holding the carbon fiber wings onto modern commercial jets is so strong that the solid titanium bolts are only there as a psychological backup for the pilots? Or consider this. A single square-inch bond of modern industrial epoxy can easily lift a fully loaded semi-truck straight up into the air without breaking. And perhaps most shocking of all, the world's first known glue was made by Neanderthals over 200,000 years ago, who dried a still birch tree bark over underground fires to create a sticky black pitch. We have been refining this exact same concept for millennia, moving from primitive campfires to hyper-automated chemical fortresses. We have traveled from the deep oil fields of Saudi Arabia, through the roaring, superheated chemical reactors, and right down to the hyper-precise robotic packaging lines. It is a journey of extreme heat, crushing pressures, and brilliant chemical engineering that completely reshapes how our modern world functions. The next time you look at a simple bottle of glue sitting in your garage or office drawer, you will see it for what it truly is, a highly volatile liquid kept in a state of suspended animation, waiting to unleash its immense bonding power. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.